I suggest you to do more assignments that will help you clearly understand the whole MapReduce and Hadoop paradigm ecosystem framework. Assignments are actually much simpler. Neither the mapper nor the reducer are too big a program. They're simple programs. If you take any existing program, you can look at them, it is done. You have to probably write a lot more code if you're doing Java because of the classes, but otherwise, functionality wise, the actual logic or code wise, probably not more than 10 lines of code for either of the assignment, mapper and the reducer. Let us look at what you're trying to do. So objective is you should understand how HDFS works, how Hadoop system works. Technically, you can write a program in any language of a choice, then use a streaming service. But since all the book examples are given in Java, I would suggest you or recommend you to use Java for the assignment, but not mandatory. If you want to use something else, then you should be able to do, but as long as you follow the MapReduce paradigm to do things work out. Assignments fall into two categories. One is that basically use only computation. That means there is no data as a input as such. Even though we said Hadoop primary is to do large data processing, or we could do distributed computing as well. So some assignments involve only most computing, no input data. Some may involve data. If this involves data, then there has to be data file that needs to be used. And these data files should be on HDFS file system and not on local file system. If it is data as input, you have to probably generate a data file, put on HDFS system, and then run the program. Other type of assignment is called streaming, which I haven't discussed yet, which I'll probably be discussing day after tomorrow. But only difference is in streaming based programming, rather than reading data from a file directly, you read from standard input and write to standard output. That's the only difference. Otherwise, there's no difference. But you have to use the streaming interface of the Hadoop. So you should know how to use a streaming interface of Hadoop. Do that. That's what you should basically be doing. Those of you still not very comfortable with Java would like to use Python. Maybe even though some assignments I haven't said streaming, you can use streaming, you can specify your data file as input to the streaming, and then write a mapper or reducer. So make your own choice, work yourself the way you want to do, and continue. As a group, you are expected to do one assignment, but I encourage you to do more because that will clarify you the entire working of Hadoop. Currently, there are no bonus marks for early submission and doing more assignments, but doing more will certainly help you understand the entire gamut or ecosystem of Hadoop and HDFS as well. Those who haven't made the group, still make the group. I still see there's some group still left. Those who haven't done, do so. All questions involve Hadoop programming. 1 to 10 are basically based on HDFS-based files or computation. So if there is a file should be in HDFS. Last two questions are based on streaming. But those who want to use streaming in 1 to 10, that could be fine too, as long as specify what you're trying to do. Submit your program in MS Teams under the assignment. Along the program, do provide I have not given that write a read method, do provide a read me what you had done, how to invoke a program, what your findings are, what your results are. And submission date is 19th May, which is about, you can say 2 weeks from now. Further, after that, I'm going to schedule some time with each team, and with 10-minute interaction, you have to explain me what you had done. I would like to ensure that each team member understands something rather than one team member doing it and others keep quiet. Anytime a team member has a query, you send me an email. I request that always copy the other two team members as well. It's difficult for me to find out your email, something might have changed. So anytime any team member queries, please do copy your team members as well so that they also understand what is happening. Otherwise, I'll end up assuming that you are the only one doing it, the other team members are not doing it, and then when I ask you the interactions in team, you might have a little tough time. So please follow the protocol. Let me start now all the 12 questions. Question number 1 is a variation of the example program that we ran using quasi-Monte Carlo method for estimating the value of pi. I'm using the word estimating and not computing. Computing would require precise calculation. Estimating means we're trying to, based on some heuristics, we're trying to estimate, which may or may not be correct. But as more and more data points get, we'll probably get a better value. In the example we did in the class, we looked at the case of circle inscribed in a square. And then we said, if radius of a circle is 1, then the side of the square would be 2. So if I were to divide area of a square over by the area of this circle, that means area of circle divided by area of a square, that comes pi by 4. Because pi r square by 4r square, that gives you pi by 4. So pi would be 4 times this ratio. So extending this logic to a cube and a sphere. So consider a sphere of some radius r. The volume of the sphere is given by 4 by 3 pi r cube. Inscribe this cube in a cube so that each side touches the cube, the 6 sides. Again, the dimension of the side of cube would be 2r. So volume of the cube would be 8r cube. And that means if I take the ratio of volume of the sphere divided by volume of cube, is going to be pi by 6. So to compute pi, I could multiply this ratio by 6 and get the value. So how do we get the value of volume of sphere and volume of cube? Volume of cube, so we basically take a 3D coordinate geometry, look at a cube with the coordinates of 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, 1, all the 8 coordinates. You'll get that. And if you take this equation of the sphere, that is x minus h square plus y minus k square plus z minus m square is equal to r square, where r is the radius of the sphere and hkm the center point. So if you were to take r is equal to 1, you can simply find the ratio. So essentially you estimate some random number of points, which is the number of points in a cube, which is the input parameter, generate that many random points in 3D space, x, y, z, where value is lying between -1 to +1 for each of the x, y, and z coordinate. If the points satisfy the equation, that means within the sphere, a point doesn't satisfy the equation, that is outside the sphere. So total number of points which were taken would represent the area of the cube, and total number of points that satisfy the equation of the sphere would basically give you volume of the sphere, and then you find the ratio of all those points within the sphere versus total number of points. That would give you pi by 6, and hence then you can basically decide the value of pi. So there is an extension of the quasi-Monte Carlo method You can look at the program, and as we have said, we are given the program, so you can look at the following way. Find, opt, so you see you get this opt Hadoop sources. So if you were to extract the sources, so I have the sources. If I extract jar xvf, sources got extracted, and you can see Quasimodo Parlo. So you have this program, and if you look at this, is the program which you can look at. It as the Java program, which basically uses two dimensions, circle and a square equation given here, and you can extend this program, modify the program to 3-point coordinates HKM and work with a given input, and that is what basically will understand how to run your the Java program. So input would be number of mapped instances. That means how many mappers you like to run. Second input is total number of points in a cube. And you basically run that many number of times. So also have one more input, that the how many tries you like to do, or it doesn't matter. Run that many instances, find the estimates in the mapper, and the job of reducer would be to take the average of each of the mapper, and that would basically give you value of pi. The more number of points you take, more accurate results you will get. Less number of points you take, less results you get. Yeah, any questions, please? So anyone who has a question, please feel free to ask. I'll stop here. Anyone has a question, please feel free. This question number 1. No. So you write a mapper and reducer which will do the job, and that's basically what this program is about. Run this program. When you update the README, look at what challenges you faced, what did you solve. Run on your local system, install Hadoop, that's what I said. Make sure you install Hadoop on the laptop, run through it, play with it, and understand how the program works. It would take you a while to understand this program, but once you understand this, it will become a lot more easier. So this would require first generating that many 10,000, 100,000, or a million point right into a file. That becomes the input. That will be done a split to mapper, and then each mapper would compute a pi, and then reducer would basically do an estimate and work that way. That's all I'll basically expect you to do. So work with it, run it, and then see how does it work out. Any questions or any clarification on this? Otherwise, I move to question number 2. If no, let's move to number 2. This is, previous case was estimating the value of pi, because you are taking a number of points with randomly. We're assuming the total number of points represent the area of the cube. That need not be always true, because there are always some gaps, as we call it estimation. But now we'll try to compute the value of pi, which will be correct. There's a formula pi given by 2 by pi is equal to square root 2 by 2 into 2 terms square root of 2 plus square root 2 by 2 into 3 terms square root of 2 plus square root of 2 plus square root of 2 by 2, and continue this way. The more number of terms you get, more would the accurate value of 2 by pi would be. So essentially the program is, there is no input to be generated. You need to know the number of mapped instances you need to run, the number of terms that you need to use. So take it a random number, generate some value less than that number, and do number of tries to run so that you can get the average. So each mapper would run certain number of tries based on the, so your number of mapped instances, each mapper would run number of tries based on different value or number of terms, find the average, and then the mapper would give an output, which is this the value of pi based on the number of terms, and the reducer job would be to take all such values, find the average, and that would be the value of pi. Since here we are computing the value of pi, this value would be a lot more closer, and the more number of terms you get, the better results you get. So this should give you better accurate results than the question number one, which is quasi Monte Carlo method. So both programs give value of pi. One is estimating and one is computing. Any team that would like to clarify, please ask questions. Otherwise, I'll proceed to the next question. If no questions, let me move on to question number 3. This requires input. So first is you have to generate an input of random numbers. So create an input file that contains at least 1 million plus random numbers. Let's 6-digit number, 7-digit number, whatever number you want to generate. So generate some random numbers, more than 1 million. And then the job is to find which number appears maximum number of times and which number appear minimum number of times. So that means for each number that is appearing, count the frequency, and once you count the frequency, then you find out which number occurs maximum times, which occur minimum times, and that's the job of basically this. So again, when you create a larger file, you run the number of mapped instances. Each instance will get a part of the file. That's why you need to make sure that each instance get the respective slice of the file. When you get the respective slice of the file, you run that instance, and each instance should give you frequency of each word or each number that is appearing. And job of reducer is get the frequencies of each number and then find the number which appears maximum, which appears minimum, and does the output. And that is what is expected in this question. So this is file based. Write a simple random program. A 2-line Python program can generate you as many number as you want, write into a file, put onto HDFS systems. And again, whatever steps you do write in a README file, which you upload into your MS Teams assignment area, and what results you got, what did you learn, any challenges you faced, do all that details so that I can understand how things are working. The team doing question 3, if any doubts, please feel free to ask. Okay, let me move on to question 4. For example, like this, the input to the previous question. So look at 1 appears 4 times and 4 appear only once. So output expected would be 4 times 1 and 1 times 4. But if input happens to another one, if the numbers which have, so 2 numbers appear same number of times, then both should be appearing. Then what is expected? Next question. Again, generate a file having million plus numbers, integers, positive integers. Make sure you have million plus entries, generate maybe 6-digit numbers, random numbers. Job is to find all the prime numbers in the input file. So generate a random input file, put onto HDFS system, and then each mapper would get a slice of this input file. Each mapper would produce the prime numbers into this input file, and job of reducer is to get all these prime numbers on each mapper and then find a unique list and then give that output. And that is what the question is. So it involves generating a million plus random integers, put onto a HDFS file system, run mapper. Mapper would generate from this file only those numbers which are prime numbers with the respective frequencies, and then reducer is to look at list of all the unique primes and give that, and that's basically the overall program. So team doing question 4. If any doubts, clarifications, please do feel free to ask so that I can clarify. If not, I'll move on to question number 5. This is about computing golden ratio. A golden ratio is given by consider a line which has two parts A and B. So now points should be such a place such that the ratio of B by A should be equal to ratio of A plus B by B, which is, let me put in brackets. So if you can find the value A and B on a line so that ratio of A plus B by B is same as B by A, then this ratio is called golden ratio. It's called golden because it's naturally appealing. So they say when you take a photograph picture, what should be the photo size? If your height and width of the photo follow the golden ratio, that is considered the most suitable size. If you look at how do they identify the most beautiful face, they again look at the ratio of the gap, the nose, eyes, this. If they follow the golden ratio, that's considered the most uniform face. So golden ratio has one utilities. So your job is to find the golden ratios. This is a compute-oriented assignment. This can also be computed using following recurrence relation. Take some number x0, compute x1, then computing x1, compute x2, and so on and so forth. And if you keep computing, doesn't matter what your starting number x0 is, after a certain number of terms, you'll basically get xn, which is a golden ratio. So if golden ratio g, you'll find g is equal to 1 plus 1 upon g. That is what the golden ratio is. You find the golden ratio. So input is again number of mapped instances, that how many mapper you would like to run, number of computation steps, how many iterations you want to do in one experiment, what should be the initial value. So initial value should, you take a, let's say 10 and take a random number, because different mappers should start with different random numbers. And when you run the number of computation steps, you basically see you're getting some answers. The reducer would basically take this output of the mappers and produce that. So again, this is compute oriented. You don't need any input file. Run the program, different mappers, look at it, how the different mapper puts the output, check the output. You can even print it out and then see, find the golden ratio. And this is the assignment number 5. Any team that has a question, please feel free to ask now.
Yes, can you explain? What are number of mapped instances?
See, we are doing distributed computing. So that means there should be number of mappers. Now, since you are doing a local on laptop, I'll probably expect you to run 2 or 3 instances, just not one, because we are not running a program locally. So Hadoop ecosystems, remember when you run our pipe program as example program, we did specify number of mapped instances. Let me see if I can show you where we did that. MapReduce examples. No, this is the setup. No, not this. Let's say in this or next one. No, not in this, the number 4. Just give me a minute. The HDFS commands. Okay, that will be next one. Running programs. Look, when I said this yarns are Hadoop MapReduce running a pipe program, 16 number of instances, 10,000 some number of points, sample points. This is computing using circle. Say number of map is 16. That means there will be 16 mapper programs would be running. And each mapper would be using 10,000 points. So when you run this program, you would basically say writing input for map 0, map 1, map 2, and map 15. If we look at the Monte Carlo program, let me see if I can show you that. This is the Monte Carlo program. If you see, it creates number of maps. Let me just say, is it too small for you to see? Just 1 minute, let me come to the point.
Okay, sir, take your time.
See here in this, let me increase your font if you can't. So it's writing input for map number 1, map number 2, and that is what you see in this case. And how does it give input to the mapper? So generating, look at number of maps. For each map, it's generating a data. And then in the actual mapper program, it's basically giving an offset from the single input file, because we split is logically doing a split. And for each mapper, it is giving that point and doing computing. So what I said is, you should be able to specify mapper program. So if you're doing Java, example is given, you can run that. If you're trying to use Python, which I will be trying to do, so you have a MR job MapReduce, which is mostly for chaining. You need to figure out how to create number of mappers. I'll also figure out how to create number of mappers. I haven't used MR job. So, but there should be a way to specify number of mappers and then should split into a number of mappers and do that. So that is what the input I'm saying.
So
The number of mappers.
if I used Python,
Yeah.
Can you tell me what the command should look like to run the program?
I don't know. I need to figure out. First, what you are running a program, what you gave me was local. You were not even using Hadoop.
Yes.
I think syntax is first you have to use Hadoop, and there should be a way to figure out how to run number of mappers.
Yes,
Because
and
yeah, go ahead.
number of computation steps and
That's the input.
this, yes, this X naught should be argument, sir, for
Yeah,
the
so
Python
value
program.
is 10 and X naught should be a random number less than 10. So different mappers should get a different value of X naught. So you can give input as, let's say 10 to each mapper, and then each mapper would take a random number less than 10, that becomes X naught. Point is each mapper should have a different starting point, starting value, not the same starting value. Otherwise get the same values.
Yes. Okay, sir. Thank you, sir.
Okay. I'll still find out how to specify the number of mappers. It may take a while, but if not, you have to identify the mapper. And if MRJob doesn't give that support, then either you go to streaming mechanism, which we'll discuss. You can still continue to use Python. It uses streaming to do this work, and streaming interface do automatic splitting with minor change, or we can do MRJob. Streaming I'll discuss probably day after tomorrow. So either way should be fine. Okay.
Okay.
Any other team?
So, should we print the output for each instance, sir?
For a debugging purpose, if you want to, yes. But finally, it should print the output by the reducer.
Okay, sir.
Okay. Any
Sir,
other question?
please share the slides with us, sir, the teaching slides.
The all is in MS Teams. If you go to class materials, let's say go to the Teams, we're in 8A, go to Files, class materials, and you have all the slides here, PDF and PPTs.
Sure, sir. Thank you.
So all these which I talk, they're always available onto this. And all these sample programs from the authors are available into the program.
Yes,
So
sir.
whatever example program author is used, like word count, word piece, everything, you can find it right here. I uploaded that as well. Like chapter 5, which is simple, which I'm going to run maybe tomorrow, we can look at that and do all that stuff. Okay.
Done, sir. Thank you.
So if the output is
I'm
so
not
that
hearing
does
you.
that
Repeat again.
so the output, sir, if it's taking number of instances, mapped instances,
Yes.
so in that case it should look like one, and for one, I mean for X naught taken as 1 and its golden ratio, for X naught taken as 2 and its golden ratio. Is that how it should
Yeah.
look
So
like?
one instance will give you, so let's say start x naught is equal to 1, and let's say number of computation step is 100. So mapper 1 would start with 1, run 100 times, get a value. Mapper 2 would start with, let's say, value 2, run 100 times, get a value. Mapper 3, let's say start value is 5, it will run 100 steps to get a value. So each mapper would give the output. Job of reducer is take all these 3 inputs and then find the average. That's the output of the reducer.
Okay, got it.
Okay. Any other question? Look like it is this assignment is being done by some teams. Okay, I didn't see no question from other teams. Let me move on to the next one. This is a question of consider a deck of playing cards. We know that deck has 52 cards. We pick one card, put it back in the deck, reshuffle it, pick second card. We'd like to know what is the probability that second card we picked is the same as the first card. So in general, this probability should be 1 by 52, but we want to experimentally verify it. And since we want to run large number of instances, single machine may not be good enough. So we'll run this on a Hadoop infrastructure. So basically, again, number of mapped instances, and each instance should number of tries, find the values. So you can represent each of 52 cards with a number between 1 to 52. That means you first pick a random number x between 1 and 52. Second time pick a random number y between 1 and 52. If x is equal to y, you know you got that answer. If not, you failed. So keep trying it again and again. At some point in time, you'll probably get the number, and that means, let's say, after 500 tries, you got the same random number. That means probability in that trial is 1 by 500. Some trials this may happen after 10 picking up, that means probability is 1 by 10. So you take number of tries for each map instance, run that many times, compute, and that will give the average. So expected is 1 by 52, but depending on number of tries, answer would be different. Now each mapper would give the expected probability. The reducer would take all these outputs of mapper, then find the average, and that would be your answer. So expected value would be 1 by 52, but if you take less number of tries, your answer could be quite deviating. And that's the question. Any clarifications on this question? No, then I move to question number 7. This is a famous what is called birthday paradox or birthday probability. Question is, what is the class size should be so that probability that two students have the same birthday in the class is more than 50%. And this number is set to be around 23. So can we verify that? So we're estimating the class size where two people get the same birthday. So again, you can represent birthday as a number between 1 to 365 days of the year. All you need to do is pick one random number between 1 to 365. Let's say this is called x1. Pick second random number x2. If x2 is equal to x1, then you know class size is 2, minimum has to be 2. If not, pick x3. See if x3 is equal to 1 or x3 is equal to 2. If either of them, then it becomes class size 3. Keep repeating it. Keep repeating the random numbers. And some point in time, you'll find that the number you picked up is already there in the previous number picked up. So when you pick number xn, if it is 1 of x1, x2, xn minus 1, that means the class size is n. So each try should give you an output of n, the number of students, and each mapper should run this experiment number of times. Let's say each mapper runs this 10 times. Each time you get a different answer, but find the average, that gives average class size. And then job of reducer is get the output of each mapper and find the average. So expected answer would be somewhere around 23. It may be 22.5, 23.4, but around that you should get the answer. And we are basically saying we are estimating this over a large number of computation, distributed computing, and Hadoop framework fits well into this. So team who's doing this assignment, any questions? If no, I'll move on. Question number 8. This is basically finding the step for random walker. So let's look at the next diagram, which is based on this. Consider a grid of 2n plus 1 by 2n plus 1, which are located in the middle. Let's say you close your eyes, or then decide whether to go left, whether to go right. So you take a random number between 1 and 4. If random number is 1, you move one step left. If random number is 2, you move one step right. If random number is 3, move one step up or one step down. So each step, pick a random number. So do a random walk. Sometimes you go left, right, up, down. You keep doing it. But at some point in time, you'll reach the boundary. So when you reach the boundary, so assuming if the coordinates is size is 2m plus 1, center is 0, 0, that means this line would indicate value would be the coordinate for this line. Basically, we are saying when you reach this line, y value is minus m. So once you reach y coordinate as minus m, that means you reach the boundary. Or if you reach a y coordinate of plus m, you reach the boundary. Or you reach the x coordinate of plus m or x coordinate of minus m, you reach the boundary. So each time when you move from 0, 0, it could be minus 1, comma 0, it could be 0, comma 1, it could be 1, comma 0, or it could be 0, comma minus 1, and keep incrementing it and see have you reached the boundary. Count the number of steps, and that is what tells you the random walk. Again, do number of tries. Each mapper will do number of tries, count the number of steps. So basically, you need value of grid size m, and then you have to basically say what is the random number of steps. And if you do large number of repeat times, you'll basically get the average number of steps for a random walk. We are using distributed framework to compute the number of steps for a random walk so that person who is basically in the middle can come out of the grid. And that's the question. Any clarifications by the team doing question number 8? Please feel free to ask, otherwise I'll move on. So I'll move. So any team has asked me, then I'll continue the next question. So question number 9 is probability of success in a deal. So it was famous television deal. So question is like this: there's a player and there is a deal maker. So deal maker presents 3 doors. So this is the game host. Game host represents those 3 doors, and behind 3 doors there is a prize. Only one of the doors has a prize. So contestant is asked to choose one door. Let's say there are door 1, door 2, and door 3, and there is a prize behind one of the doors. Let's say there is a prize behind door 2. Now contestant can choose either of the door. It doesn't know which door is behind the prize. Let's say contestant chooses some door. Let's say contestant chooses door 1. Now the game host opens a door which doesn't have a prize. So if there's a prize behind door 2, contestant chooses door 1. Game host will open the door 3 and say, look, door 3 has no prize. And the game host now asks contestant, do you want to stick to your decision or do you want to change the decision? So all we want to do is, what is the probability of success if contestant changes the decision or does not change the decision? Because game host is showing one door which doesn't have a price. So intuitively you think now price has to be either between door 1 and door 2, or should be 50%. It turns out that if a contestant changes the decision, probability of success is 2 by 3. If it doesn't change the decision, probability of success is 1 by 3. And this is what you want to verify using the distributed computing. So run number of tries. Each mapper run number of tries, gives the output, and job of reducer is get the output of each mapper, find the average, and your answer should be close to 2 by 3 if you change the decision. So you are basically looking at if contestant changes the decision, what's the probability, and that is this question number 9. Question number 10, same golden ratio, but using Fibonacci series. So you take 2 random numbers, using the random number A and B, keep generating Fibonacci series, A, B, A plus B, then A plus B plus previous number B, and keep adding. So you generate the nth number. If you take the ratio F1 plus 1 by F1, that again gives you golden ratio. Doesn't matter what 2 numbers you start with. If you go deep enough, if n is large enough, you'll come to the golden ratio. So input is number of mappers, number of tries each mapper would do, number of items in the Fibonacci series, because you run once, run twice, so number of tries, and you want to start with different random 2 numbers, not same random number, because each mapper, each try should have started with different random numbers, but answer should be close to that. And job of reducer is get the output of each mapper, find the average, and so you get the golden ratio, which will be close to 1.60, something of that kind. And that is what the golden ratio would be. Question number 11 and 12 are based on streaming, which I'll discuss in a day or two, tomorrow or day after tomorrow, probably day after tomorrow. I'll take both the classes because today I've taken this, so we'll take both the theory classes day after tomorrow. So it is same as question number 3, but using streaming. So whatever input you give, We'll use a streaming mechanism of Hadoop, and that basically your mapper and reducer would use standard input to read the data and compute. So basically we are doing the, again, 1 billion plus data, find maximum and minimum, and then do that part. So people who are trying to do other, they can still do same map streaming interface and do the comparison. That would still be fine. So we want two output, maximum occurrences with what the number, minimum occurrences for which number, and question number 12 is again using streaming interface for a prime numbers. So generate a large number of input, which will be given as standard input to your prime programs. So mapper, each mapper would give only list of primes. User would take all these inputs from the mappers and produce a unique list of primes, and that would be this program. So question number 11, 12 differ from 3 and 4, only in that 3 and 4 read the input directly from a file, where the 11, 12, they read input from standard input using streaming interface, which we'll discuss maybe day after tomorrow. That's all for the assignment. Again, once you do that, I recommend you to do more assignments than what is given to you. That will clarify, understood the concept, how things work. At least do for one with file input, one with computation, so that you get both the flavors of processing large data and doing large distributed computing. Again, due date is 19. There'll be no extension, and it has to be submitted in MS Teams, and the what it is. Again, somebody has still a query, send me an email. Make sure to copy all the team members so that the team can be in sync and do that part. Any questions, please feel free to ask. Otherwise, I'm done. Thank you.
So should we submit a zip file in the MS Teams?
No zip file. You can submit multiple files. So one README, one a program, what you're doing, instruction the README, what you have done. You can submit multiple files. It need not be only one file.
Okay, sir.
Okay. So zip will do extra work for me, so don't submit zip file. Thank you. I'll make a note. Do not submit zip files. I need to open. And README should be .txt. So that moment to click on assignment, I can see what you have done. So all programs should be text file, no graphic output, just plain text files, output, and the program as well.